There is a world of exquisite blue at the very edge of our solar system. It hangs in the dark like a sapphire marble. This is Neptune. From our vantage point on Earth, through the lenses of powerful telescopes, it appears serene, a calm and beautiful sphere. But this beauty hides an extreme truth. Neptune is a place of unimaginable cold. Its upper atmosphere is one of the most frigid places we know of. A realm so cold it defies our everyday understanding of weather. How can a planet so large, so dynamic, be so profoundly frozen? The story of Neptune's cold is a tale of immense distance, of faint light, and of a hidden internal fire that paradoxically drives the most violent winds in the solar system. The mystery begins with a simple observation. Temperatures in its high clouds plummet to around -218 degrees Celsius. That is more than twice as cold as the coldest temperature ever recorded on the surface of the Earth. The primary reason for Neptune's deep freeze is its staggering distance from the Sun. Our Earth orbits the Sun at about 150 million kilometers. This is the Goldilocks zone. Neptune resides in the far, dark suburbs of the solar system. It orbits at about 4.5 billion kilometers, 30 times farther. The energy from our star must travel across this vast expanse. As sunlight travels outwards, it spreads out, like ripples from a stone. The farther the ripples travel, the weaker they become. By the time sunlight completes its 4-hour journey to Neptune, it's incredibly faint. In fact, it's only about 1/900th of the intensity we get on Earth. From a platform in Neptune's clouds, the Sun would be a bright point, not a warming disk. That tiny point can't provide significant warmth. This lack of solar heating reshapes Neptune's atmosphere. On Earth, sunlight is the engine of our weather. It warms the land, it warms the oceans, which warms the air and creates winds, and it drives the water cycle. On Neptune, that engine is barely ticking over. Sunlight only warms the highest, thinnest layers, and only slightly. With no strong external heat, the upper atmosphere just radiates away its minimal heat. So cloud tops are frigid, cold enough to freeze terrestrial life instantly. Compare the planets. Mercury is scorched by the sun. Earth is temperate. Mars still gets enough sunlight for seasons and weather. But for Neptune, the sun is a distant acquaintance. The planet is disconnected from the solar system's main heat source. It must look inward, not outward, for energy and dynamism. This solar starvation is the foundational truth of Neptune, the starting point for everything about this cold blue giant. While distance from the sun explains why Neptune is not warm, the planet's composition explains why it looks the way it does and why it cannot easily trap the little heat it receives. Neptune is not a solid, rocky world like Earth or Mars. It is a gas giant, or more accurately, an ice giant. It is composed primarily of the simplest and most abundant elements in the universe, hydrogen and helium. These gases form the bulk of its massive atmosphere. Beneath this vast gaseous envelope, there is no solid surface to stand on. Instead, the pressure grows immense, and the gases are thought to transition into a strange, hot, and slushy mantle of ices. These are not ices in the way we think of them on Earth. They are a super-pressurized mixture of water, methane, and ammonia. Deep within the planet, the conditions are so extreme that these materials behave in ways that are difficult to fully comprehend. But it is a different molecule in the upper atmosphere that gives Neptune its most defining visual characteristic. Sprinkled throughout the hydrogen and helium is a small amount of methane gas. This methane plays a crucial role in the planet's appearance. Methane gas is very good at absorbing red and infrared light from the faint, incoming sunlight. At the same time, it is not good at absorbing blue light, which it reflects back out into space. This selective absorption and reflection of light is why Neptune appears to us as a vivid, deep blue. It is the same basic principle that makes Earth's sky blue, but with a different chemical actor. The methane acts like a filter, stripping the red from the sunlight and leaving only the brilliant azure hue. While this methane gives the planet its iconic color, it does not act as a significant greenhouse gas in the upper atmosphere. On Earth, gases like carbon dioxide and water vapor trap heat and warm our planet. On Neptune, the atmosphere is so cold and the sunlight so weak that this effect is negligible. The methane paints the planet blue, but it leaves it in its frozen state. So we have a world composed of simple, light gases, with a touch of methane for color. This composition is very different from a terrestrial planet, which has a solid surface that can absorb and re-radiate heat. Neptune's gaseous nature means that heat can be transported and lost in very different ways. The top of the atmosphere is directly exposed to the vacuum of space, allowing any minimal heat to escape easily. This combination of a gaseous, methane-tinged atmosphere and the profound lack of solar energy ensures that the visible part of Neptune, its beautiful blue face, remains one of the coldest places in the known solar system. The beauty is born from the very conditions that make it so inhospitable. Here is where the story of Neptune takes a fascinating turn. If the planet only received the tiny amount of energy it gets from the distant sun, it should be even colder than it is. It should be a static, quiet world. But it is not. Astronomers have measured the energy that Neptune radiates back into space, and they have found something remarkable. Neptune emits more than 2.5 times the energy it receives from the sun. This means there must be a significant source of heat coming from inside the planet itself. Neptune has an internal engine, a source of primordial heat still powering the planet billions of years after its formation. This internal heat is likely a remnant from the very birth of the solar system. As gas and dust collapsed under gravity to form the planet, the immense pressure and friction generated a tremendous amount of heat. Planets are like cosmic embers, and the largest ones, like Neptune, take a very, very long time to cool down. This slow, steady leakage of heat from its core provides the extra energy that we detect. Another source of this internal heat could be the slow process of differentiation, where heavier materials are thought to rain down through the planet's interior, like diamond hailstones falling and releasing gravitational energy as heat on their journey towards the core. Now, one might think that this internal furnace would warm the planet's upper atmosphere, but it does not. The heat from the core is trapped deep within the dense lower layers. It does not easily radiate up to the cloud tops. Instead, this internal energy does something else. It creates convection. Hotter material from deep inside the planet rises. Cooler material from the upper layers sinks. This constant churning, this vertical movement of gas, is what powers Neptune's extreme weather. The combination of this internal heat engine and the planet's rapid rotation whips the atmosphere into a frenzy, creating the fastest winds in the entire solar system. These winds are truly mind-boggling, reaching speeds of over 2,000 kilometers per hour. That is faster than the speed of sound on Earth. These winds drive colossal storm systems, the most famous of which was the Great Dark Spot, a storm as large as the Earth itself, observed by the Voyager 2 spacecraft in 1989. These storms are not like hurricanes on Earth, which are powered by warm ocean water. They are vortices of unimaginable scale, dredged up from the planet's interior by its own internal heat, spinning in an atmosphere of superchilled gas. It is a beautiful paradox. The cold, dark world of Neptune is home to the most violent and energetic weather we have ever seen, all because of a fire that burns deep within. So, Neptune's story is one of dualities. It is a world of profound external cold born of its immense distance from the sun. And it is a world of internal heat, a relic of its violent birth, which drives its wild and furious weather. These forces conspire to create a planet of stunning beauty and extreme physics. When the Voyager 2 spacecraft flew past in 1989, it gave us our first and only close-up look at this remote world. The images it sent back were of a place more active, more complex, and more beautiful than anyone had imagined. It revealed wispy, white cirrus clouds of frozen methane, casting shadows on the deeper blue cloud deck below. The flyby gave us a flood of data, but it also left us with a universe of questions. We still do not know for certain why Neptune has retained so much internal heat, especially when its neighbor Uranus is much colder and lacks a strong internal heat source. We do not fully understand the mechanism that drives its supersonic winds or the life cycle of its enormous storms which appear and disappear over years. The interior, superpressurized ices and a potential rocky core, remains largely theoretical. Neptune guards its deepest secrets well. Today we study Neptune from afar using instruments like the James Webb Space Telescope. These observatories see the planet in different wavelengths, peering through the blue haze to study its temperature, its atmospheric composition, its faint rings, and its many moons. Each new observation adds a piece to the puzzle, refining our understanding of how ice giants form and evolve at the fringes of a star system. Our solar system is not just static points of light, but a family of dynamic, evolving worlds, each with its own story. Neptune, the last true planet from the Sun, remains a symbol of the unknown. A cold, blue beacon in the dark, a reminder of the vastness of space and the infinite variety of worlds. Frigid temperatures, faint sunlight, methane blue skies, paradoxically violent weather, a narrative of cosmic extremes. A place of wonder that challenges our understanding and beckons us to keep exploring, keep questioning, and keep looking up. The cold, distant mystery of Neptune is a rich and fascinating chapter in the cosmos.